So I have one more set of examples for you, and these are special cases that you might run into. So as you'll notice, this first example is an and inequality, and we know that because it's already written all as one thing. So this is an and, we just want to keep that in mind. So that means that whatever number we put in here should make both sides of this inequality true. So as I solve it, remember your first step was to write it as two separate inequalities. So that would be 24 is less than or equal to negative 3r, and negative 3r is less than or equal to negative 30. So then if I solve each of these separately, I divide by negative 3, divide by negative 3. So I have negative 8 is less than or, because I divided by a negative, what do I need to do with this inequality symbol? That's right, I need to flip it, is greater than or equal to r. So if I flip it around, it's r is less than or equal to negative 8. And over here, I divide by negative 3, divide by negative 3. This is 1. So r is again, I need to flip my symbol. So r is greater than or equal to 10. So if I were to graph this is supposed to be an and. If I were to graph this, negative 8 is over here, 10 is over here. At negative 8, I have a closed circle, and it's less than, so I shade to the left. And at 10, I have a closed circle, and it's greater than, so I shade to the right. But we have a problem. This is supposed to be an and inequality, but when I graphed it, this is an or. So what happens is, it's not possible for this to be true. This is impossible to be true, therefore this would be a no solution because there's no number that I can put in the center to make this an and inequality. The only numbers I could put are or. They're opposite sides here. So if it goes from an and inequality to an or inequality, then that is no solution. There's no solution. So if it starts off as an and ends up as an or, then it is no solution. However, let's look at one that starts off as an or. So if I were to take this one and solve this, remember with an or inequality, we simply solve both sides because it's already separated for us. So I divide by 3, divide by 3. So I have m is greater than or equal to negative 5, or add 4, 0. So m is less than or equal to 6. So if I were to graph this one, I have negative 5, close circle, shade to the right, and then I have 6, close circle, shade to the left. But this is an or. So remember, if I'm covering all the numbers that are less than or equal to 6, and I'm also covering, because or means it can satisfy either one, all the numbers that are greater than or equal to negative 5, well, I've shaded my entire number line, which means that the solution to this one would be all real numbers. Because no matter what number I put in there, it would always be true. So if it goes from an or to an and, then my solution would be all real numbers. So if it goes from an and to an or, it's no solution. If it goes from an or to an and, it's all real numbers.